So with no further ado, I'm now going to introduce Dr. Ben Goertzel. Dr. Goertzel is a scholar and a visionary and a world leader who is recognized in artificial intelligence. He is a researcher and serial entrepreneur. He is the founder and CEO of SingularityNet, the chairman of OpenCog Foundation, the chairman of Artificial General Intelligence Society, chief scientist of Moseley Health, and he is the chair of Humanity Plus. Ben's writings and ideas are influencing the way we perceive AI, technology, and blockchain. Thank you. And now for Dr. Ben Goertzel.
Thanks so much for that introduction, Natasha. And what I want to talk about today is one particular thing which I think is critical to all of us as we look around the world today and we think toward the amazing transhuman future ahead of us, which is, there's a lot of great technologies out there. I spent most of my life working on artificial general intelligence. We have nanotech, we'll eventually have femtotech and adotech. There's going to be cyborgs. There's going to be new types of technology and new forms of mind and reality that none of us can even imagine now. On the other hand, if we personally get old and die, then we are not going to perceive these things, right? We're not going to have those experiences. And in a sense, in the big picture, there's a part of me that doesn't necessarily mind. I mean, as long as life and joy and intelligence flourishes in the world, my own individual self and body are not the most important thing. On the other hand, a part of me is really curious and would like to be there to see what happens when superhuman AGIs go around the universe, and when scarcity is abolished on the planet, and when you have, when your phone is the size of a molecule and networked together into massive swarm computing networks buzzing around the planet, and when my great grandchildren are born and experience life on Earth, right? So I think it's not the only thing that's critical for the future by any means. On the other hand, using the advanced technologies that we're developing now to extend human life and health so that none of us needs to get old and die. I mean, it's one important thread in the transhumanist narrative since the very beginning. And I think it's something that at bottom is meaningful to every human being. I mean, I know people will say death gives life meaning, and there's some truth to that, but to me that mostly indicates that humans are very creative and innovative and able to find meaning in everything. I mean, if someone was to walk into my room now and cut off my fingers, I could write a beautiful poem about that and find meaning in it. That doesn't mean it's a good thing, right? So I think we can find meaning in death, but I think we're going to have even more meaning in radical, healthy super longevity once we can achieve it, and that the pursuit of radical, healthy super longevity can occur in sync with the advancement of other valuable technologies. I mean, AI can help with it, and doing this positive thing for humans can help AI to achieve a benevolent mindset toward human beings. So I want to talk a little bit now about some specific projects and work going on toward the end of achieving a healthy super longevity for all humans, and about some of the intersection between this and the advance of AI and the push for artificial general intelligence. So yeah, let me tell you a little bit about some of the work I'm doing now with a project called Reju, which is bringing together some AI technology we've been developing in OpenCog and SingularityNet projects toward the goal of longevity. And I think now, I'm going to talk about some of the projects I'm involved in indirectly, but there's a lot of amazing stuff going on beyond that as well, and more than can be talked about in a few minutes. I mean, Aubrey de Grey's Sense Foundation is funding and directly doing all sorts of work at remedying the damage that happens in the body as we get older and older. And Alex Zhivarenkov's in silico medicine is doing wonders, applying neural nets and simulation modeling together to understand causes of aging. I mean, there's a lot going on in the world now. We have the biotechnology, AI technology, the biological data to really deliver radical health span extension. There's certainly more scientific progress that has to be made. On the other hand, there's also sort of economic and industry structure issues that are slowing down the progress of using this amazing technology to radically extend human health span. And of course, there's always this interesting tension between perceiving things as going very fast and perceiving things as going too slowly with all of these humanitarian applications of advanced technology. Because in one sense, we're progressing astoundingly faster than at any point in human history. I mean, in most of human history, life and technology stayed about the same through a human being's life, right? Whereas now, in each of our lifetimes, things are getting revolutionized over and over again. On the other hand, if you look around you and see people dying and getting sick all over the world, you can say, well, okay, it's going faster than in prior human history, but relative to the needs of saving this and this and this person's life, it is not going so fast at all. So just to highlight some of the specific scientific work I've been engaged with. So in our AI team at SingularityNet, we've been looking, for example, at the genetic foundations of supercentenarianism. So I mean, SingularityNet mostly exists to create this blockchain-based AI platform, which allows a bunch of AIs to exist all over the world and be coordinated in a decentralized, democratic way. But our AI team has been doing a bunch of cool AI things running on top of that decentralized platform. And one of these is applying machine learning and machine reasoning tools to DNA data from people age 105 years or over. And it's quite interesting. What you see in this graph is that supercentenarians just have a lot more genetic variations than everybody else. And you see here chromosome by chromosome, the orange line is the number of genetic variations in the average supercentenarian in that chromosome. The blue line is number of genetic variations in the average normal person, the control people in that chromosome. They just have a lot more changes in their DNA. And at the edge of the screen, you see something similar for fly chromosomes. And this is from work I did with Michael Rose's Genetian project some years ago. You can see that long-lived flies also have a lot more variations in their chromosomes than the normal control flies. So that, I mean, this is indicative that there is a significant genetic foundation to super longevity. Now, of course, living 105 or over, it's better than dying at merely like 80 or 90. It's not as good as living to 200, 500, or 1,000,000. But so it's not the end all. I mean, as far as I know now, I never want to die. I don't want to just live to 110 or 120. On the other hand, there's the notion of longevity escape velocity or Methuselarity, right? Like if you can extend your life merely to 110, then before I turn 110, we're going to have a lot of super AGIs that'll figure out how to make me live tremendously longer than that. And we can see that a lot of the answer to that is in our DNA. And you can use then machine learning. So using OpenCog and other AI tools, we then say, okay, there's a lot of genetic variations distinguishing supercentenarians from ordinary people. Can we specifically look at which of these variations are most important? And the AI can find some logical combinations of genetic variations that seem to be more important than other ones. So you have a variation in this gene and not one in that gene, or else one in that gene, and that has particular causal force at making you live a long time. I mean, we can also, using the gene annotation service running on the SingularityNet platform, you can then explore the whole network of biological pathways and genetic categories and try to use your human mind, which currently in many ways is still better at lateral thinking than the AI mind, though the AI is great at sifting through all the data, and try to see, what are the main concepts that tie together the genes that have the most causal force at making you live a long time. Now, this helps with understanding, but of course, with CRISPR and other technologies for actually editing the genes of living organisms like people, there's some potential to directly take these findings about genetic variations and turn them into therapies. Like we can now edit just a couple genes at a time in practice, but you can see the technology path toward being able to do a lot more gene editing. So I mean, in 5 to 10 years from now, if you have several dozen genes that you want to edit in a certain way to promote your longevity, it's not at all unthinkable that we could do that. And so we're now working using machine learning, machine reasoning, data visualization, and understanding, what are the genes that you would want to edit to make each of us be more like a super centenarian. And this is one example. Now there's a bunch of other research projects around the world by other teams that are pushing towards super longevity in their own ways. On the other hand, it's an incredibly small fraction of what humanity is doing, and even an incredibly small fraction of what the medical establishment is doing, which is really kind of ridiculous if you think about it. I mean, if you look at the world's response to the coronavirus, which is, it's inadequate in many ways. On the other hand, what you see is trillions or tens of trillions of dollars are like fabricated out of thin air by the global financial system to help with bailing out after a pandemic. I mean, just like after the financial crisis in 2008, I mean, Obama administration materialized, what was it? That was like $4 trillion or something, right? I mean, humanity, well, we have resource allocation problems, and there are far too many people suffering for that reason. I mean, we have quite a lot of resources generated by the advance of technology over the last couple centuries. We can allocate it with a lot of enthusiasm when we really want to, and we're not doing that for human life extension right now, even though if we don't, all of us are going to get old and die. And I mean, the whole healthcare system is mired in red tape and inertia with endless complications. And the mix of corporate conservatism and government regulation is really constraining progress toward using AI to its fullest extent here. I mean, one example that I'm a little bit involved with now through SingularityNet and our spin-off Singularity Studio, precision medicine. I mean, the potential there has been clear a long time, right? Like some drugs work for one person, some drugs work for another person, some therapies work for one person and for another, even outside the scope of drugs, if you're talking about herbal therapies or gene editing. And I mean, we can gather a lot of genomic information. We can get gene expression from peripheral blood. We can get, genetic variation data, clinical medical data, and we can use machine learning to figure out, based on the genomic and holistic clinical profile of a person's body, which therapies are going to work best for them. And, this is hard. It's not nearly as hard as building an AGI. I mean, we know how to do this. Very little of this happens in the medical and pharmaceutical industry now, right? And that's just because that's not what pharma companies are really structured to do. It's not how regulatory agencies are structured to think. And we're looking at this right now in COVID-19. I mean, in SingularityNet, we're working with a group that's running a bunch of clinical trials, combining multiple antivirals to help folks with COVID-19. And what you see there is the same cocktail of antivirals doesn't work for each person, right? So based on your based on your weight, based on your lifestyle, based on just intrinsic characteristics of your body that can be determined from genomics data, some people will be better helped by one antiviral cocktail, some people will better be helped by another. And we have the science to make that estimation based on applying machine learning to data from people's bodies. But why is this not the default in COVID therapeutics now? I mean, we're working on this with one group running clinical trials, and I hope that what we do will become influential. But it's remarkable to me how bad we're really brilliant at developing cool new ideas, and we're a lot worse at actually deploying these cool new ideas for our own benefit. And it's not really because of evil people in charge, although that can happen. It's the mode of social organization that has self-organized on the planet is very far from optimal at propagating the technologies and discoveries that we've made for broad benefit. And there's not any one solution to this. I think we're trying to build part of the solution with a spin-off of SingularityNet called Reju, which is sort of a membership network for people interested in living a long time, where members of the Reju network can contribute data from their bodies in a secure way to the Reju data commons. Then that's analyzed by our OpenCog and SingularityNet AI, and then we will work with pharma companies and research labs to develop therapies based on this data. And we want to make sure that these therapies are provided to everyone on the planet insofar as possible. And we also want to make sure that if there's a profit made from these therapies, then the folks whose biological data contributed to the therapies are properly compensated. And there's a whole business structure underlying this. You can look at the website rejuve.io. There's a few videos and some text explaining this. I mean, we've divided it into Rejuve Tech, which is a for-profit company aimed at therapeutics discovery, and Rejuve Network, which is the membership network of individuals contributing their data, and that's coupled together in a certain way. And underlying all this is, we want to get data from people's bodies out of the hands of pharma companies and governments who are mostly just sitting on it or using it for very limited means. We want to get that data into the mind of the AI, and the AI we're using for supercentenarian data now is great, but it's just the start. We've been doing a lot of work with neural symbolic AI aimed at longevity and COVID-19 analytics, cancer therapy analytics. And the point there is modern neural nets are very good at recognizing the patterns there in a certain data set. Symbolic AI and probabilistic reasoning is very good at abstracting and making leaps from one data set to another, like from one patient population of young people in Pakistan to a patient population of old people in the US, or from mice or flies to humans.
Hi,
So
Ben, sorry.
AI,
Sorry, Ben, I need to make you aware of the timing, as we have great questions coming from the community, and we want to leave at least 5 to 10 minutes to answer questions. So if you want to just leave a very conclusive note before we pass to the questions.
Give me like two more minutes, Marcello. Sure. But I'm happy to answer questions. I'm almost done anyway. So
thank you.
I think thanks a lot. By putting the neural net AI, which is so good at recognizing patterns, together with the symbolic AI, which is good at abstracting and generalizing, you can, I think, make some quite dramatic leaps toward discovering longevity therapies. But you need to get the data, and the point of Rejuve is to be able to gather the data from people into the AI directly and share the benefits from that, both medical and financial. So we're launching a series of apps aimed at data collection, data analysis, and then providing benefits based on this. So there's a smart fasting app aimed at people doing intermittent fasting. There's a COVID-19 oriented app that's going to launch quite soon, which it analyzes data from medical peripherals like Fitbits, pulse oximeters, digital thermometers, and we can identify pre-symptomatic infection. Like we can use AI from these peripherals attached to your smartphone to tell you a few days before you feel sick or show any symptoms that you're getting an infection. And you can use that data to guide your own behavior and tell you to be careful or get tested. You can also use that to help track infection and guide simulation models of epidemic spread. So I mean, there's an awful lot that we're doing now with AI technology to help with health and longevity, but there's a lot more that can be done. And my hope is that the results from some of the things we're doing right now will be exciting and impactful enough that they'll cause humanity to have a sort of change of heart. And the same resources we're spreading on COVID now, we're going to beat COVID. Let's have that same amount and even more resources used to beat aging, which is going to kill not just a small percent of the population, it's going to kill every single one of us if we don't intelligently deploy our technology to defeat it. All right, I think that summarizes what I had to say, and I'm happy to take some questions with the remaining time.
Fantastic, Ben. Thanks for being so quick. Truly appreciate it. We have a great community that is engaging with great questions. So I would like to pass some of them to you. We only have about 5 minutes, so I'm conscious of the time. I'm gonna take just 2 questions for you. So the first one comes from Mr. Lonwabo, and the question is there a correlation between supercentenarians and the genetic variation and people with higher level of genetic diversity in their heritage?
We don't have the data to determine that, actually, because almost all the people who are well documented to be supercentenarians are of European extraction. But that's just because reliable data about when people were born in China and Africa and so forth is hard to come by from like 110 years ago. So we have no idea. That it's a very good research question.
Okay, thank you. Coming from Freedom Seeker, what technology will allow us to radically improve our cognition or emotional capacity for empathic awareness and connection to others? Well,
the first answer to a question like that is once we get human level AGI, assuming it's benevolent and instead of malevolent or indifferent, once we get human level AGI, then all the other problems are solved, right? Now, on the other hand, you could argue if we don't improve human beings' empathy and reasonableness both, then our odds of creating a benevolent human level AGI are lower, because unempathic, unreasonable human beings are more likely to accidentally create a nasty AGI. So then we never build the digital savior, right? So, I mean, of course, just like one could use CRISPR or other gene editing technologies to prolong human life, in principle, one could use those technologies to create, to upgrade human empathy and human compassion and human reasonableness. Like we could, it seems that the Chinese government has discovered a lot about the genomics of intelligence and IQ, although they have not publicly released that, and it's politically incorrect to do similar studies in the West, right? So I mean, you can understand the genomics of intelligence, you can understand the genomics of compassion, and you can do gene editing to make smart and compassionate people. On the other hand, we may not want to wait for that, right? And I think another interesting application we built using OpenCog and SingularityNet AI was called the Loving AI Project. And with that, we took the Hanson Sophia robot, and we had the Sophia robot do meditation guidance and some sort of consciousness therapy, deep listening, and try to get people in a very peaceful state of mind. And we found that for around 30% of the participants in these trials, they had a really profound positive consciousness experience from interacting with this robot. So I would say that through AI, which is engineered to sort of push people's emotional buttons, as Sophia does with her facial expressions, but in an emotionally positive way, rather than oriented toward like selling them stuff or convincing them to vote for someone, right? I mean, I think that this can have a very positive impact. And so using AI for meditation therapy, counseling, consciousness expansion, medical research, longevity therapy, using AI for these things, it will both help to put humanity in a more compassionate and reasonable position, and it can help increase the odds that once that AI transitions into AGI, it's more benevolent and compassionate and can help us with all the other problems. So that's what we should be doing. Unfortunately, most AI on the planet now is oriented towards selling, killing, spying, and market speculation. But hopefully the tide will turn on that.
Nice, thank you, Ben. I'm going to take the last question for you, which comes from one of our speakers, Didier Cournel, who's asking, before COVID-19, I was more optimistic about data plus money plus AI equals good results. Now it seems that we have a big problems in trash in, trash out. How could you avoid this problem?
Well, I think a key point is that, actually, I didn't understand the last, a big problem with what? Trash in, garbage out?
Yes, correct.
Oh, I mean, I think a pandemic really highlights the need for some methodical process and preparedness in doing things. That's all. I mean, gathering medical data from people takes time because the human biology has a certain process to it, right? And you can't just jump up and say, well, now we need to use AI to solve this problem. Oh, but shit, I forgot to gather any data to feed the AI. So I mean, I think if we had been systematically gathering data related to infectious disease, then when COVID-19 hit, we have AI models trained on other infectious diseases, and they could do transfer learning to learn things about COVID. Instead, you know, our great President Trump in the US defunded a lot of the work on infectious disease in the CDC for the years before COVID, because there was no infectious disease happening at that moment, right? I mean, we see this in many applications. So one of the projects I'm working on now is aimed at nursing robots. So what we're looking at, can we make robots to be nursing assistants to help with many different issues? I mean, in COVID, it's obviously useful because a robot won't spread COVID as much as a person. But in elder care, nursing robots can be very, very valuable also, and they can do assessment of neurodegenerative disease, and they can help give mental stimulation to aging people to slow the onset of neurodegenerative disease. But in training the AI for this use case, then we would really like to have like longitudinal data on people with neurodegenerative disease. So we'd love to have video and audio data of people with Alzheimer's over 5 years, so we could study the progression from mild to medium to long-term Alzheimer's. But I mean, you can't gather that longitudinal data on people immediately, right? That takes some time and some forethought. And the thing is, amazing amounts of data are being gathered about people right now, but they're sitting in the private repositories of like intelligence agencies and pharmaceutical companies and so forth. So we need to be aggregating that data ongoingly and analyzing it all the time, so that when a crisis hits, you know, the data is there, the AI models are trained, and then we can respond rapidly. And you know, we approach that better in an advertising and military context than in, say, public health. Right?
Thank you so much for your talk, Ben.